Here I am coming in like a wrecking ball, back with some more videos. Today we're going to do some modeling, which just means word problems. So I figured I'd demonstrate some hard ones for you so you can watch them a couple times and get the hang on how to do those types of problems. So again, mathematical modeling, just translating words into algebraic expressions. It's always good to start with a verbal model and a picture, whatever the situation requires. And taking that and putting it into an equation is modeling. So the first one we're going to do says we have a rectangular family room is twice as long as it is wide, and its perimeter is 84 feet. Find the dimensions of the family room. So we got two variables, two dimensions we need to find, which means we need two equations. So to help us find that, let's draw a little picture. So here's our rectangular family room. We'll say this is the width, this is the length. All right, our first equation is it says the length twice as long as it is wide. So L equals 2W. We also know the perimeter is 84, and we can express the perimeter by doubling the width, because we got two of those sides, and adding it to 2 times the length, because we got two of those, it's a rectangle, and we get 84. Set that equal to that. Now we are going to just use some substitution. Plug in 2W in for L, and we get 2W plus 2 times 2W equals 84. That'll simplify down to 6W equals 84. Divide by 6, and 6 goes into 84 14 times. So that is our width. We know the length is twice the width, so the length is going to be 28. There you go. Start off with an easy one. Not that that was easy, but it's easier than the other ones we're going to do. Alright, the next one says, sorry, it's been a while. Alright, we have an investment. You invest a total of $10,000 into an account that makes 4.5% and 5.5% simple interest. That just means after 1 year, you make exactly 4.5% off your money. There's no compound interest. So during 1 year, so after 1 year, you earned an interest $508.75. So how much did you invest in each? So one time I had a student, Kyle Kim, ask, well, why don't you just put all your money into the 5.5% account? Thought that was pretty funny, and it made a lot of sense, but it's a math problem, so it's not supposed to make sense. But no, just kidding. Sometimes you don't know how much certain accounts will yield. So that's why. So let's define our variables. Again, we have two variables. We got X, we could say that is the account invested at 4.5%. And Y, we can say that is the amount invested earning an interest of 5.5%. So if we express those variables as what we invested in each account, we can get our first equation, which is X plus Y is equal to 10,000. Now we need another equation because we got two variables, and this is going to be an equation describing the interest we earned. So simple interest just means if you invested X dollars into an account that yielded 4.5%, then X times 0.045 represents the amount of money you made on top of the 10,000. And in the other account, you made Y times 0.055. In total, you earned $508.75. Now, you just do some substitution, plug in, and just for the sake of saving time, I'm sure you could solve this system. Let me just show you the first step. You could subtract X on both sides and get Y is 10,000 minus X, and then plug it in right there. And then eventually you're going to get Y is equal to $5,875. And then if you invested 10,000 total, X is going to be 10,000 minus that. So $4,125. All right, skip some steps right here. But again, that's just solving a linear equation. Just isolate Y, divide. All right, let's try another one. The next one is the related rates problems. You're going to grow to love these, and I may be saying that sarcastically. But the trick is, the first thing I'll say about these is you want to use this right here. Oop, I didn't do something right. Oh, wrong. There we go. You want to use this. Distance equals rate times time. And you also want to draw a picture. So this question says two planes which are 2,400 miles apart fly towards each other. Their speeds differ by 60 miles per hour. They pass each other after 5 hours. Find their speeds. Alright, so here's going to be my picture. Here's going to be plane number 1, right there. Here's going to be plane number 2. Their distance between them is 2,400 miles. We don't know the distance that they each traveled individually, so let's call the distance of one plane on the left d1 and the distance of another plane on the right d2. So the first thing I notice is that the distances of the two planes combined, d1 plus d2, after 5 hours, because that's what it says in the question, is going to be 2,400. Now we want to use distance equals rate times time to express the distance of each plane. So the distance of plane 1 we could say was equal to the rate of plane 1 times time. And we know that time was 5 hours, so we have the distance of plane 1 was 5 times r1, where r is the rate of plane 1, which we don't know. And the distance of plane 2 was the rate of plane 2 times time. So we know time again was 5, because they both started at the same time and then passed each other after 5 hours. So we can put a 5 right there. But for rate, we know that their speeds differ by 60 miles an hour. We don't know which one's faster, we don't know which one's slower. It doesn't matter, we're just going to pick one to be the slower plane. So we'll say this rate of this plane 2, was equal to the rate of plane 1 minus 60. 60 mile an hour slower. Alright, that's just one way to do it. You could have said r plus 60. You could have said r1 minus 30 and r1 plus 30, as long as they had a distance of 60. Alright, so now we're going to take these two and plug them in there in our original equation, and we get 5 times the rate of plane 1, which represents the distance of plane 1, plus r minus 60 in parentheses, r1, because we're now in terms of plane 1, because it's the rate of plane 2, r1 minus 60, because it's the rate of plane 1 minus 60, differs by 60, times 5 equals 2,400. Now we're going to distribute and solve. So when you're going to skip like 2 steps here, you're going to distribute the 5, get 5r1 plus 5r1 is 10r1, and then minus 300, because that's negative 60 times 5. Add 300 to both sides, and you got 10 times the rate of plane 1 equals 2,700. And then you get the rate of plane 1 is 270. Now, if you plug that back in to this right here, the rate of plane 2, which was the rate of plane 1 minus 60, you get the rate of plane 2 was 60 mile an hour slower, because we said that plane 1 was going faster. So that's going to be 210. And the question asks them to find your speeds. So you got 210 miles per hour and 270 miles per hour. Alright, this question, very similar to the last one, but has some differences. Now we know their rates, but we're looking for time. So it's going to be similar, except now we're going to solve for t. So two cars are 500 miles apart, moving directly towards each other. One car is moving at a speed of 100 miles per hour, the other at 70. Assuming the cars start moving at the same time, how long does it take for the two cars to meet? So let's draw our picture again. So we have car 1 here, car 2 there, heading towards each other, and they went 500 miles total. The distance of car 1, we can call D1, D is a D, and the distance of car 2 is D2, and we can express those in terms of rate and time, because distance equals rate times time. All right, now, so we don't know the distance car 1 traveled, so the best we could do is write it as 100 times t. Every hour, t is in hours because the speed is in miles per hour, something to pay attention to. All right, if you're given a speed in miles per hour, your time is in hours. So every hour, the distance that car 1 travels is 100. So that expression is represented by 100t. And car 2, every hour, is going to travel 70 miles. So that distance is represented by 70t. So together, we know that those distances, we want to find out when it equals 500. So how much time has to go by? So we're going to combine like terms and divide by 170. And then we get the time is 500 over 170, which is a little less than 3 hours. It's about 3 and 16/17, or about 2.94 hours. If you wanted to find this in minutes, you could just take 0.94, multiply it by 60, that's a 4, and you get about 56 minutes. So like 2 hours and about 56 minutes roughly. Alright, the only way you could really make this question harder is they left at different times, and you would have to know, how much longer or later one car left than the other. So if it said like car 2 left an hour later, then you just make t for car 2 t minus 1 for 1 hour or something like that. And we'll work on those in class. Alright, let's do one more. This is a solution problem. So mixing different solutions of different concentrations. So this one says, how much of a 50% salt solution should we mix with 10 gallons of 35% solution to get 40% salt solution? So we're going to go from 35% solution to 40% solution, and we're going to make it more concentrated by adding 50% solution. So 35% saltwater solution means if there's 10 gallons of it, you have 3.5 gallons of salt over 3.5 gallons of salt plus 6.5 gallons of pure water. So that's total. So 35% salt solution is 3.5 parts salt to 10 parts total water and salt. So that's what we currently have, and we want to get it to 40% solution. So we have 0.4, that's what we want this to equal to. Right now we have 3.5 parts salt over 3.5 plus 6.5 total. That's just 10. Let me just write 10 so we're not confused. So 10 parts total. And we're going to add 50% saltwater solution. So every gallon of 50% saltwater solution is going to add a full gallon to our denominator, because our denominator is total. And since we're not adding 100% salt, pure salt, we're adding only 50% salt solution, every X amount of gallons of 50% saltwater solution is going to add 0.5x gallons of salt. So we add another 2 gallons, that's 1 gallon of salt, 2 gallons total. And we want to solve this to see how much we need to get to 40. So now we're just going to cross multiply. So cross multiply, and you get 4 plus 0.4x is equal to 3.5 plus 0.5x. Solve for x, we get 0.1x is equal to 0.5. Divide by 0.1, and you get 5 gallons. So the final answer is we want to add 5 gallons of 50% saltwater solution to 10 gallons of 35% saltwater solution to get 40% saltwater solution. Alright, hope you found this video helpful. We're going to practice these in class. I just want you to see a couple before we did. Alright, have a good night.